Light is energy emitted by accelerating electric charges, most often electrons and atoms. This energy travels in a wave that is partly electric and partly magnetic. These waves are called electromagnetic waves. Visible light is a portion of the family of electromagnetic waves that includes radio waves, microwaves, and X-rays. The range of electromagnetic waves is called the electromagnetic spectrum. The lowest frequency of light we can see appears red. The highest visible light, violet, has nearly twice the frequency of red light. Electromagnetic waves of frequencies just lower than red are called infrared. Things that radiate heat give off infrared waves. Electromagnetic waves of frequencies just higher than violet are called ultraviolet. They're responsible for sunburns. Light is energy carried in an electromagnetic wave generated by vibrating electric charges. When light strikes matter, electrons in the matter are forced into vibration. Just as a sound wave can force a sound receiver into vibration, a light wave can force charged particles and materials into vibration. Exactly how a material responds to light depends on the frequency of light and the natural frequency of electrons in the material. Materials that transmit light are transparent. Glass and water are transparent. The electrons of atoms in glass can be imagined to be bound to the atomic nucleus as if connected by springs. Electrons in glass have a natural vibration frequency in the ultraviolet range. In ultraviolet light, resonance occurs as the wave builds a large vibration between the electron and the nucleus. The energy received by the atom can either be passed on to neighboring atoms by collisions or re-emitted as light. If ultraviolet light interacts with an atom that has the same natural frequency, the vibration amplitude is unusually large. During this time, the atom makes many collisions with other atoms and gives up its energy in the form of heat. That's why glass is not transparent to ultraviolet. When the electromagnetic wave has a lower frequency than ultraviolet, as visible light does, the electrons are forced into vibration with smaller amplitudes. Less energy is transferred as heat. The energy of the vibrating electrons is re-emitted and transmitted as light. Glass is transparent to all the frequencies of visible light. The frequency of the re-emitted light is identical to that of the light that produced the vibration to begin with. The main difference between light in a glass and in a vacuum is a slight time delay between absorption and re-emission. This time delay results in a lower average speed of light through a transparent material. In a vacuum, the speed of light is a constant 300,000 kilometers per second. We call this speed of light c. Light travels slightly less than c in the atmosphere, but the speed is usually rounded to c. In water, light travels at 75% of its speed in a vacuum, 0.75 c. In glass, light travels only about 0.67 c, depending on glass type. In a diamond, light travels at only 0.40 c. When light emerges from these materials into the air, it travels at its original speed, c. Infrared waves with frequencies lower than visible light vibrate not only the electrons, but also the entire structure of the glass. This vibration of the structure increases the internal energy of the glass and makes it warmer. Glass is transparent to visible light, but not to ultraviolet and infrared light. Materials that absorb light without re-emission and allow no light through them are opaque. In opaque materials, any vibrations from light are turned into random kinetic energy. The materials become slightly warmer. Metals are also opaque. In metals, the outer electrons of atoms are not bound to any particular atom. When light shines on metal and sets these free electrons into vibration, their energy does not spring from atom to atom. It is re-emitted as visible light. This re-emitted light is seen as a reflection. That's why metals are shiny. Our atmosphere is transparent to visible light and some infrared, but almost opaque to high-frequency ultraviolet waves. Clouds are semi-transparent to ultraviolet, so you can get a sunburn on a cloudy day. Ultraviolet also reflects from sand and water, so you can sometimes get a sunburn while in the shade of a beach umbrella.